Hello, welcome back, everybody. Hope you all enjoyed the good holiday, and now you are ready to come back and dive more into the Bitcoin smart contract with me. So again, as a short intro for people who have missed the previous ones, my name is Xiaohui Liu. I'm a founder and creator of Script. So in this series, we are going to dive into the details, get some hands-on experience on our latest, TypeScript framework called ScriptContext to write Bitcoin smart contract in native TypeScript. So we have gone through a series, in the last year, and this year we're going to continue. So I'm super excited about today because I'm going to cover two very important topics. And number one, you can see here, is called ScriptContext. The second one is kind of built upon this to how to leverage ScriptContext to maintain state in so-called UTXO smart contract, which is usually considered impossible, right? So first concept here, ScriptContext. What is the ScriptContext? So when a smart contract, in ScriptContext runs, right? So if you think about when you call a smart contract function method here, so you pass it in some arguments, right? So this are the first things you can think of the smart contracts. Basically, the public methods they can see, right? So they can see these arguments. There's no problem, right? It's like any other function. But there's another type of almost implicit arguments that the smart contract can also see. So because eventually the smart contract is going to be compiled down into the basic level called script, and it's going to be run. So that's why we name it ScriptContext. You can think of it as implicit arguments. When you run the smart contract, they can also your contract can also access to. A little bit similar to like a global variable, but instead of global, now is under every instance the smart contract base class. So in general, it covers, roughly, right? So here I've shown you two transactions. One has 3 inputs, 3 outputs. The other transaction one has 2 inputs and 2 outputs. And it turns out they have a relationship. So the first input of the transaction one is spending the second output of transaction 0. I just give you one example. So when the smart contract code is here, right, in the output, in the script part of the output. So when this smart contract runs, you can, what is the context it's getting. So roughly it can, consists of 2 parts. The first one is transaction 1, roughly. You can you can know all its inputs, you can know its outputs. I mean, indirectly, you can know all the fields, like say version number or even a log time field. So first one is the spending transaction. The second part is, it's kind of like a self reference. Basically, it knows the UTXO, the contract is receiving, all the information. So I'm just to pause a little bit here. Any questions so far? I think this is if you have not played with Script contract before, this may be something a little bit surprising. Any questions so far? Okay, if not, let's go dive into a little bit more details. What does this look like? So this is the exact spec, the structure for ScriptContext. So you can see here, I mean, there are 2 types of fields. The first one is I called it earlier before. It's called it's information about the UTXO, the smart contract code is. So you can see it has all kinds of UTXO information. You have this value, you have this is pretty much is the script. And also you also know the reference, the so-called out point. Which transaction it is in, identified by transaction ID, and also which output, which of the outputs, within this transaction that the contract is in. So it has all the information about the UTXO. And also outside of the UTXO, it also have the kind of like the spending transaction information. So for example, you can say, so it has versions, it has, for example, log time, right? But also, if you see here, I think this is very important information. Previous outputs, what does this mean? So basically, it just hashes, it's a hash of all the inputs. So instead of the inputs directly itself, because this then you can be very big, right? Because inputs, it can contain many inputs and each input can be arbitrarily big. So here, it doesn't contain the hash previous is pretty much you can think of all the out points, the input UTXOs that we are spending, and then it contains the hashes. Same for here, because if you zoom in a transaction, you can also see each input has the out point, but also the sequence. So it also hashes all the sequence together, and the same for the outputs. You have all the outputs, and this hash outputs contains the hash, the SHA, the double SHA-256 hash of all the outputs out there. So you can think about this two. First one contains the inputs, the second one contains the output, but not directly. It's a little bit indirect because this is only the hash. But once you have hash, I will show you how to construct, the pre-image of these inputs and outputs. Okay. Any question here regarding script context? Okay, so far so good. Let's move on. So let me show you one simple example. How do you leverage this? So for example, here, I'm showing a very simple, contract called the so-called check log time verify. So what does this mean? So basically it says, if you want to unlock, you cannot unlock anytime. That's a deadline. That's the earliest time you can, so-called mature time, you can set it here when you deploy it. So basically it's the earliest time that you can spend this transaction, right? Because usually in a smart contract, it's stateless. So that is timeless. There's no concept of time. But a lot of time, right, we want to constrain our contract. For example, you want to bet with Alice want to bet as a Bob, and then if Bob does not respond in a certain time, it's lock up some escrow. You got the time. You got to say, hey, after certain deadline, if Bob is not responsive, Alice can take his money back, right? So this is a typical use case, involves time. So here, using this example, okay, the syntax is very simple. So if you want to know the script context, you just say, so for every smart contract, it has this property called CTX. Basically, it's the context, script context. So you just say this dot context and then dot unlock time. This will give you the log time of the spending transaction. And then you just say, hey, this log time has to be, at least this mature time. So when you try to unlock this, you will make sure the unlock time, will be at least the specified mature time. So that means if you want to, call this method before this time, it will fail. So in this way, you can kind of get the introduce time and trustlessly into your contract. Any question regarding this simple contract here? Okay, seems smooth. All right, let's move on then. So next, we are going to show you how to maintain state in a so-called Bitcoin UTXO model. Again, as a reminder for people who have not heard of this term before, UTXO simply stands for unspent transaction outputs. So if you think about the Bitcoins, there's no concept of so-called account or wallet. It's not in your wallet. It's distributed across so-called the UTXOs. So basically, each transaction, for example, here, has some outputs, and if it's not being spent yet, and then new transaction can reference to them and spend them. So basically, each transaction you can think of take some, existing UTXOs, destroy them by spending them, and then create some new outputs, and this cycle keeps going. So this is how the UTXO model work. So if I just mentioned, once you spend a UTXO, it's gone, right? It's destroyed. So all the information contained with it are gone. So that's why usually, this contract, the native contract, you can think of it as only for one time. Once you spend it, it's gone. You cannot maintain some kind of a internal state, right? So that's, one reason people, prefer or favor some kind of like a account based, because in account it's very easy, right? Each account you can have an internal state and then you can maintain it. For example, you want to have a voting, let's say voting contract, or you want to have for example, auction contract, right? You want to maintain the states who has voted for whom, right? Or how many bets you have, and what is the amount of each bet, right? And betting from who, right? You want to keep all this information. So a lot of time, the contract has to maintain some kind of an internal state. And then the question here is, is it possible if I only have, UTXO, how do I maintain state? Turns out that the answer, I'm not going to, give you too much of a thinking space here. I'll just give you the answer. The answer is yes. You can so-called use UTXO-based contract to maintain state as well. So what is the high-level idea here? It's also very straightforward. So if you imagine we have in our contract, in ScriptContext contract, you have the so-called properties, right? And then properties, you can also declare it as state. So basically in the output, the output is almost like divided into two parts. One is the so-called smart contract code, and the other part is so-called state. So if you see our property, if you declare this, property decorator, we have an argument, we have a parameter, basically whether this property is going to be part of state or not. So if you declare it as true, it will just, hey, regard this as a mutable state, right? So in the UTXO model, then in the code part, in the smart contract, the code is pretty much the contract. You are going to specify, hey, when this new transaction, the spending transaction is spending the old output, you have to, you go to a new state, but at the same time, okay, here's a key part. Here's a key idea. At the same time, you are going to duplicate the code part. You're going to carry over and continue the smart contract without modifying it, right? Because how can we enforce this? Because remember, right, we just talked about the TX, the script context, and that's how we enforce it. Because when the code here, they can almost place constraint on the outputs of the new transaction, right? So you don't not only specify the rules for the state to transition, but also it maintains the invariant. Say, hey, the smart contract has also to keep going. So once you have the first step, almost by deduction, right? So you can spend it again, and then say this code will make sure again it's duplicate here again. So keep going. So in this way, that's how a UTXO model can maintain state. I think this may be a little bit also surprising to some of you if you've not heard about this concept before. So any question here? Okay. Yeah, it seems you guys are very refreshed after New Year break. So that's good. Let's go to an example then. So let's pause a little bit here. and go to the examples. Let's see. Do I have to reshare or? Can you guys see the browser here?
Yeah.
See my browser? Okay, that's good. So we just talked about the script context. By the way, everything can be found in our new, in our documentation site. Just go to script.io, script.ts. So I just talked about script context. You can find all the documentation here, which is pretty much what I just covered. And then let's go to an example here, stateful contract. So you can also find all the specific, detailed documentation here, but we just cover the basic idea, and let's see how it works in practice. Right? So let's get one simple example here. I just show you this one of the simple, if not the simplest, stateful contract called counter. So what does this do? This contract, so basically it initialize the counter usually to 0, and then it just every time you call this internal method public method called increment, it's going to pretty much, as the name suggests, right, increase the internal counter by 1. Okay, so up to now, so as I said, if you want to maintain a state, previously we only show the property, and we never care about what the parameter here means. So basically, it means whether this property is going to be part of the mutable state. So by default, it's false, right? So meaning, you cannot mutate this. You cannot change it's not going to be part of the state. It's going to remain the same. You're not going to change it. But here, first you have to declare the count. The property, this argument has to be true, meaning is it going to be part of the state and it's mutable. Again, I don't have to remind you this, but if you have a typical constructor, there's nothing special here. And then also here, after you declare as a stateful property, you can just use it as any other property. You can read it, you can write it. Right here, I just show you can do both by incrementing it. Okay, here, this is a little bit of there's a more explanation for this one. So what does this do here? Anybody has a guess here? Anyone? Okay, so let me go ahead.
So does it check the output is the same as checks that the script hasn't changed? The context script.
Okay, that's one part. I think that's the major part. How does it check that then?
So it looks like it's building the state, and then what's it doing there? This hash outputs. I don't know. You'll have to tell me.
I have an idea. I have an idea because I might butcher this bit, but I did quite a lot of work on this before, and I completely confused myself. And hopefully I might have got it now, but I'm not too sure. Anyway, so every time you call in a stateful method, for example, stateful property, for example, this count plus, this is actually internally, it's changing the context, the hash output. So the hash output is actually changing, right? And then what you're doing is you're asserting the hash outputs, and then you're building a transaction from the inputs from the UTXO, right? With the state. So you're basically concatenating the state with the UTXO, and basically both should be the same. So you've got the hash outputs, which has automatically been updated because you've done a this.count plus, and then a hash 256 of the current UTXO with the new state should be equals. That's kind of what I understand, but I might have butchered this.
Yeah, close enough. Any other people who want to take a step here? Yeah, very good insights here so far. Okay, I think this because it's a one-liner, I think that probably we should do a better job to change this a little bit because there's a lot of information that's compact here. So let's decompose it one by one. Okay, first of all, we have this. Let's actually go to the innermost part. So this part, anybody who wants to take a guess, what does this mean? If you still remember, what is the script context here? So if we go back here, right, this dot CTX is just the script context, right? So this, if you, I call this dot CTX dot UTXO value, this pretty much just give me the, what is the Satoshi amount for the UTXO I'm spending, correct? Okay.
Yes.
So this is also a library function. For every smart contract, you have this function called build state output. So what does this mean? So the state output, I just, as I just mentioned a little bit of earlier time, is if you look at the graph here, you see the graph here? You guys can see the graph, right? Okay. So basically, yeah, you build the output with the latest state, but also with the old, with exactly the same contract code before. So this is what this function actually does. It does a lot of internally it's very complex, but when you use it, you don't have to care. Basically, it just when you call, for example, if we are here, when you call this function, you are pretty much after you mutate the state, right? You just duplicate the code here and then create a new output containing both the new state and the old code. This is carried over here. Okay, this gives you the output for the new UTXO. Okay, so bear with me. Okay, I hope you are still following me. So here, basically this says, hey, I'm building a new output. So what is the Satoshi amount? I'm still using the old one. Basically means, hey, do not change. I mean, this can be, technically can be anything. I just, in this example, you just say, hey, this counter, nobody can take money out of this contract because, the Satoshi amount has to remain the same, right? So the input here is, what is the output amount for the new state for the UTXO that contain the latest state? Make sense? So basically, this one says build a new output that contains the latest state, and this parameter is just what it if you know UTXO, right, contains two parts. The first one is the script part, and the second part is the Satoshi amount, right, the value. So this is just the value. Make sense so far?
Yeah.
Okay. So once you have this, you have now built the output, right? And as I said before, this thing is just the hash of all the outputs. Okay, right? So if you want to go back to the documentation here, so this is you have the hash outputs, right? It's a double SHA-256 of all the outputs, right? So if this equation holds, if I only have one output, if I double SHA-256 of it, equals this one, and then this assertion makes sure I only have one output, and the output contains the state, like the state, and because of this, it also contains the old Satoshi amount. But this this example is just one example. You can also say, hey, I want to change the amount. That's no problem. But the critical thing is here, how do you carry over the state? You keep updating the state. This is how it this is almost like a template. You can almost always do this. So this is just a specific example. You have one output only contain the new state, but also you don't change the Satoshi amount. You cannot withdraw from the contract. I hope this makes sense, but if not, let me know here. I think, yeah, this one sentence, maybe we should break it down, but this contains a lot of information. Any comments?
I have one comment and question really. Just so this .build state output, this is implicitly behind the scenes building the output. So what I'm trying to say is, if, for example, if you remove the assert line, if you remove the complete line, the contract will actually, will execute, but the outputs will be wrong. Is that correct? So behind the scenes, implicitly, it's building the, you're not just building the actual state output for use on the assert line. Implicitly, it's actually building the state output, right?
This is just asserting. This is just asserting that the output hasn't changed, isn't it? But so in some cases, you might want the output to change, yeah.
Not quite. Basically, you almost always have to assert this is true because you are placing constraints on the outputs, right? You can say, hey, you can carry over state, but also you may have some other, any other constraints, right? It doesn't have to be stateful. For example, you probably want to do this if you say, hey, this contract can only be redeemed by Alice, identified by some public key, right? You can say, hey, then the outputs must be the hash 256 of, some pay to public hash outputs that contains Alice's address, right? So you almost always have to do this because this is the only way you can enforce, hey, the output is actually what I want. So just in this case, it's a special case. We want to maintain the state across two UTXOs. So that's why we build a stateful contract, state output. But you can build, let's say, pay to public key hash, P to PKH, P to PK output. That's no problem. Does this help?
Yeah, that's what I mean. That's what I was trying to say, was that basically without calling this build state output, implicitly behind the scenes, if you're calling that implicitly behind the scenes, it's actually creating the output, right? For example, if you remove the complete line, the complete assert line, the contract will work, right? I mean, the increment public method will function, but the state output will not be correct. Is that right? I mean,
yes.
Yes. What I'm saying is the build state output is actually doing something behind the scenes. It's actually building the actual output, correct?
Yes. Okay. Let me even simplify it. So I just give you one example, right? You can even, let's say, build a normal pay to public hash output, right? Script. So you can also have another. We can also have another function called, if I change this to say, build a P2PKH output, right? And then we just build another output with, the specific script there, script part. But the only difference here is, I'm building another type of output that contains the latest state and the old script code. So that's only, it's all, again, build another output. It's just the script has to be follow certain pattern. In this case, it has to carry over the old smart contract and it contains the latest state. So it does two things. First, it makes sure the latest state is in this output. And second thing is, the script part is the same with the old script.
Okay, thank you.
Okay, good question. Anything else? Okay. Okay, I think that, the devil is in the details, so I would strongly recommend you to first go over the script context, play with it a little bit, and then, just this assignment, today's homework is want to try is, get up the stateful contract ready, and then make sure you can run its test and it passes. So here you can also say, you can also test it locally as what we have done before, even though it's a little bit different from all the contract we have seen before, which is so-called non-stateful. Okay, so I would definitely recommend you to go over this specific example. So basically what it does is you pretty much, if we can go back here, right? You can, in the counter example, how do you test it? So what we have done here is hey, I initialize the state. The state here is just a simple counter, right? It's an integer. Let's say put it 0. And then if you want to spend it, you have to make sure the new state is 1, right? Because that's, 0 increment once is 1, and then you spend it again, it must be 2. If you put any other number here, this thing will fail. The contract evaluation will fail you. That's how you maintain state, right? Because without this script context, so here, let's go back a little bit. Without this, usually when you send, let's say you Alice send Bob some Bitcoins, the Bob can spend it whatever way he wants, right? So the script context is an advanced technique you can think of. If I send you Alice and Bob some money, Alice can also dictate how Bob spend the money. Right? It's just one use case. For example, Alice, maybe he's a parent, he can send some money to his son, Bob, but he only wants to say, hey, Bob, you can only spend the money, I don't know, buy some, books, or, pay for your transportation to school or something, something like that. You can constrain it here. So this script context allows you to, this pretty much is almost like a super smart contract, but on steroid. That's the way I think about it. So for people who have played with script before, so this underlying, under the hood, is pretty much the Paxa so-called op push TX under the hood. But right now, thanks to the TypeScript, which is everything else, you don't have to know anything about, the op push TX. This pretty much is a wrapper. So you can just regard this almost like global variable in this. So you can called CTX, you know everything. So you don't have to know all the details here. So strongly recommend you to go over this test example and then get the IDE ready and to go over this. It's also in the example. It's also in the examples GitHub repo, so you can also play with there. But I strongly recommend you go from scratch to build the contract yourself and write the test also, and make sure you pass. Okay, that's all I want to cover for today. I hope this is, I think this is pretty much more complicated than the things we have covered before, which is much more straightforward. But if you have any question, right, we're always in the Slack. We're also in the Discord channel, so you can always ask us over there. I think this is a very powerful mechanism. Pretty much this always surprises people who's coming from account-based smart contract, because they, usually for one reason or not, they think you cannot maintain state in the Bitcoin model, UTXO model. So hopefully I've convinced you this is not the case. So I'm looking forward to see what kind of new, once you open this, almost like a floodgate, you can get all kinds of, contract, right? For example, you can do games, right? Purely on-chain games. For example, tic-tac-toe or chess, because it's just the state here, this is simple. It's just one simple counter as an integer, but you can be arbitrarily complex, right? So that opens a lot, almost entirely new field for all kinds of contracts. You can even simulate all the contracts on account base. For example, Ethereum, right? You can have voting. You can have, I talk about auction. You can have anything you want. Games, anything you can think of. So I would strongly recommend you to explore more. Okay, any concluding feedback here? All right, seems you are good. So please go back, and then before the next session, finish either counter or some other, check log time, verify. Make sure the test passed, and then you can even go to deploy on the test network, or even go deploy on the mainnet, because it's very cheap anyway. So thanks for coming, and Happy New Year. I'm looking forward to share more of what we have done, in the coming weeks. See you next time.
Well, thanks.
Bye. Okay, thank you. Bye-bye.
Thank you. Bye.
Thank you. Bye. Good night.